The main knowledge in atoms, ions, and isotopes, we said that the difference between atom, ion, and isotopes, atom is electrically neutral. What's meant by neutral? It means number of positive charge protons equal number of negative charge electrons, or positive equal to negative, like Na11 or Cl17. We said that protons equal to electrons. So in case of sodium, proton equal electrons equal 11. In case of chlorine, protons equal electrons equal 17. This means that atom electrically neutral, number of positive charge equal number of negative charge. While in case of ion, what is meant by ion? The charged atom. What is meant by charged atom? Atom after losing or gaining electrons. In ion, protons not equal to electrons, maybe positive ion or negative ion. Positive ion refers to losing electrons. So proton is greater than electron. Like, for example, if we have Na positive, protons equal 11, while electrons equal 10. Why electrons equal 10? Because this positive refers to losing electron. While in case of negative ion refers to gaining electrons. So this means that electron is greater than proton. Like, for example, if we have Cl negative, so protons equal 17 and electrons equal 18. Why it is 18? Because it is gaining one electron. Isotopes. In isotopes, atoms of the same element with same number of protons and different number of neutrons, or same atomic number and different mass number. Like, for example, if we have C612, C613, C614, you will find that all of them are carbons. So atoms of the same element with same number of protons and different number of neutrons, or same atomic number and different mass number. All of them protons equal electrons equal 6, but neutrons is the difference. 6, 7, 8, 12 minus 6, 13 minus 6, 14 minus 6. So this means that protons equal protons, electrons equal electrons, but neutrons not equal to neutrons. After that, in any element, like Na1123, this number is considered as number of proton, or number of electron, or atomic number, while this number is considered as mass number, or nuclear number, or sum of protons plus neutrons. The difference between two numbers, mass number minus atomic number, is the number of neutrons. So this means that protons equal 11, electrons equal 11, atomic number equal 11, mass number 23, nuclear number 23, sum of protons and the neutrons 23. Number of neutrons equal mass number 23 minus 11 equal 12. And the difference between atom and ion, for example, if we have Na and Na positive, the difference in the number of electrons only. So difference in electrons only. After that, reactions, chemical reactions between acid and base. And the reaction between acid and base is considered as metal, metal oxide, metal hydroxide, metal carbonate, or metal bicarbonate. Again, reactions between acid and base. Acid react with a base. This base is considered as metal, metal oxide, metal hydroxide, metal carbonate, or metal bicarbonate. The reaction between acid with a metal forms salt and hydrogen, while metal oxide or hydroxide, salt and water. Metal carbonate or bicarbonate, salt, water, and carbon dioxide. Like, if we have the reaction between H2SO4 plus Zn, H2SO4 plus ZNO, H2SO4 plus ZNOH by 2, H2SO4 plus ZnCO3, H2SO4 plus ZnHCO3 by 2. First reaction between Zn and H2SO4. Acid with a metal. Displacement reaction. Zn SO4 plus H2. ZnO plus H2SO4 double displacement. Zn SO4 plus H2O. Zn SO4 plus 2H2O. Zn SO4 plus H2O plus CO2. Zn SO4 plus 2H2O plus 2CO2. Again, reactions between acid and base. Base is considered as metal, metal oxide, metal hydroxide, metal carbonate, metal bicarbonate. Metal, acid with a metal, forms salt and hydrogen. All of them will produce salt. Metal oxide or hydroxide, salt and water. Metal carbonate and bicarbonate, salt, water, carbon dioxide. Like the reaction between Zn and H2SO4. Single displacement, it will be ZnSO4 plus H2. ZnO with H2SO4, it will be double displacement, ZnSO4 plus H2O. Salt hydrogen, salt with water, ZnSO4 plus 2H2O, the difference in the balance. ZnSO4 plus H2O plus CO2, ZnSO4 plus H2O plus CO2. This means that when acid reacting with a metal forms salt plus hydrogen. When acid reacting with metal oxide or hydroxide, it will form salt plus water. When acid reacting with metal carbonate or bicarbonate, it will form salt plus water plus carbon dioxide. The reactions between acid with a metal from salt and hydrogen. Metal oxide or hydroxide, salt plus water. Metal carbonate or bicarbonate to form salt, water, and carbon dioxide. So this is a reaction between acid with a base. So acid can react with a base as a form of metal, metal oxide, metal hydroxide, or metal carbonate. So the reaction, acid reacts with a metal to form salt and hydrogen. Like Mg with HCl, Mg plus 2 HCl gives MgCl2 plus H2. Acid react with metal oxide or hydroxide to form salt and water. Acid react with metal carbonates to form salt, water, and carbon dioxide. How can we write the ionic equation? Or bicarbonate, salt, water, and carbon dioxide. How can we write the ionic equation? As we said, ionic equation in ionic equation, we said that for solid, liquid, or a gas, as it is. While in case of aqueous, must be separate ions. Like, for example, if we have NaCl plus AgNO3 gives NaNO3 plus AgCl, aqueous, 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 and solid. For any compounds to be aqueous, we have positive and negative, positive and negative, positive and negative. For the solid as it is, AgCl, solid. So positive, Na positive, aqueous. Cl negative, aqueous. Ag positive, aqueous. NO3 negative, aqueous. Na positive, aqueous. NO3 negative, aqueous. There is repeated ions that is called spectre ions will be cancelled. Like Na positive with Na positive, NO3 negative with NO3 negative. So the remaining Cl negative aqueous plus Ag positive aqueous forming AgCl as a solid. This is the ionic equation. Again, ionic equation, positive, negative, positive, negative, positive, negative. Solid will be the same as it is. Positive cancelled with positive, negative with negative, remaining Cl negative, Ag positive gives AgCl. Another one, if we have Zn plus H2SO4 gives ZnSO4 plus H2. Solid, aqueous, aqueous, gas. Zn will be the same as a solid. Positive and negative. In case of H2, it must be 2H positive. So if we have any number, must be written before. 2H positive aqueous plus SO4, valency of SO4 is 2. From this one, this is the valency of SO4, negative 2 aqueous, gives positive then negative. Valency of Zn transition to aqueous plus SO4 to negative plus H2 as a gas. Okay, the spectral ion. Sandra, which one will be removed? Repeated ions.
The SO2 negative 4.
SO4 negative 2, SO4 negative 2. So the remaining Z
Zn,
will be solid plus
the 2H plus aqueous,
gas
the Zn positive,
plus
and the H2, which
as
is
a
a gas.
science field. Okay, another one. If we have Cl2 plus 2kBr gives 2kCl plus Br2. In this one, if we have Cl2 as an aqueous, Br2, Cl2 as a gas, 2kBr as an aqueous, and then as a liquid. Abir,
Yes.
okay, Cl2
Cl2
as a gas.
minus. And then
Cl2 as a molecule,
yes.
the same.
Yeah. Yes.
In case of solid, liquid, gas, as it is, only aqueous must be separate. Okay, so gas as it is, and also liquid as it is. We are two liquids. Okay, positive, negative. It will be 2K
plus
aqueous plus 2
Br minus
gas.
would give 2K plus Cl minus plus
Okay.
Br2.
The repeated ions. Which one?
2K plus
2K
would be
plus,
cancelled.
2K plus. So Cl2 as a gas plus
2Br aqueous.
aqueous
2Cl minus aqueous plus Br2 liquid.
Okay, excellent. Thanks for you. Okay. 2K plus 2NaCl, yes, 2KCl, or 2 Br2 plus 2Ki, yes, 2KBr plus I2. And then this here as a gas, and this is a liquid, aqueous. Yusuf. Br2
We remove the BR.
plus positive and negative. Okay, so it will be
Okay.
2K positive aqueous plus 2I negative aqueous gives positive negative 2K positive aqueous plus 2Br negative aqueous plus I2 as a liquid. The spectral ions.
We remove the potassium.
Potassium. Okay. So 2K positive with 2K
Yes.
positive. Okay, 2K positive with 2K positive. Remaining Br2 as
The
a gas plus 2I negative aqueous gives 2Br negative aqueous plus I2 as a liquid. NaCl plus AgNO3 gives NaNO3 AgCl. AgCl as a solid as it is. Positive, negative, positive, negative, positive, negative. Repeated ions. Na positive, Na positive. NO3 negative, NO3 negative. Cancel. So Ag positive with ACl negative, aqueous, forming AgCl as a solid. Zn plus H2SO4 gives ZnSO4 plus H2. Solid as it is. Gas as it is. And then H2SO4, to be separate ions, the number must be written before. 2H positive aqueous and SO4 negative 2 aqueous. Zn 2 positive, SO4 2 negative. SO4 2 negative, SO4 2 negative, so Zn solid 2H positive aqueous gives Zn aqueous, so 2 positive aqueous plus H2 as a gas. Cl2 plus 2KBr gives 2KCl plus Pr2. Cl2 as a gas, as it is. Pr2 as a liquid, as it is. 2K positive plus 2Br negative. 2K positive plus 2Cl negative. 2K positive is 2K positive, cancel each other. So Cl2 as a gas plus 2Br negative aqueous gives 2Cl negative aqueous plus Br2 as a liquid. Br2 as a gas plus 2Ki aqueous gives 2K Pr aqueous plus I2. Gas as it is, liquid as it is, 2K positive, 2I negative, aqueous. 2K positive, 2Br negative, aqueous. 2K positive with 2K positive cancel each other. So remaining Br2 gas plus 2I negative aqueous gives 2Br negative aqueous plus I2 as a liquid. Displacement reaction. In displacement reaction, we have single displacement and double displacement. What is the difference between single and double displacement? In single displacement, it depends on the reactivity series. The most reactive metal displays the less reactive metal. But in double displacement, it didn't depend on the reactivity. For example, in displacement reactions, if we have Zn plus H2SO4. So Zn is more reactive than H2. It should be ZnHSO4 plus H2. While in case of Cu plus H2SO4, no reaction. Explain why. Cu is less reactive, so it can displace. So for single displacement, it depends on the reactivity, the strength. But in case of double displacement, like CuO plus H2O, 2SO4, CuSO4 plus H2O. So in case of double displacement, it didn't depend on the reactivity. But in case of only single displacement, it depends on the reactivity. The most reactive metal can displace the less reactive metal. This is in case of single displacement. But in double, no need for the strands. Okay, Mg plus CuSO4 gives MgSO4 plus Cu. This means that Mg is more reactive than Cu. Al plus Fe2O3 gives 2Fe plus Al2O3. This means that Al is more reactive than Fe. And Mg plus CuSO4 gives CuSO4 plus MgSO4 plus Cu. How can we write the half equations? Mg as a solid, so as it is. Cu2 positive, SO4 2 negative gives Cu as a solid as it is. Mg2 positive, SO4 2 negative. SO4 2 negative is SO4 2 negative, cancel. So Mg plus Cu2 positive gives Cu as a solid plus Mg2 positive. Also the same, Al with Fe2O3. In case of Cl2 plus 2kBr gives Br2 plus 2kCl. In halogens, Cl2 is more reactive, displaced Br. So it will form 2kBr plus 2kCl plus Br2. In case of any half equation, aqueous, and then the spectral ion will be removed. So 2k positive with 2k positive, remaining Cl2 gives 2Br negative, Br2 gives 2Cl negative. And also in precipitation reactions. In chemical tests, test of carbon dioxide, as we know that, the test of carbon dioxide is lime water. So for lime water, be turbid or murky or cloudy. This means that the gas is carbon dioxide. So what is the test of carbon dioxide? By passing through lime water, it becomes turbid or murky or cloudy due to the formation of calcium carbonate. So calcium hydroxide, this is a lime water reacting with carbon dioxide to form limestone or calcium carbonate. So the test of carbon dioxide passing through lime water to becomes turbid or murky or cloudy. For sulfate, what's the test of sulfate? Sulfate, we have barium sulfate as a solid. So when we're reacting any metal sulfate with barium chloride, it will form barium sulfate as a solid, white precipitate. So the test for sulfate, by reacting with barium chloride, it will form white precipitate. In halides, by passing through silver nitrate or lead nitrate, it will form, in case of chloride, white precipitate, in case of bromide, white yellow or creamy, in case of iodide, yellow. So in chemical tests, for carbon dioxide passing through lime water, it becomes turbid or murky or cloudy due to the formation of calcium carbonate as a white solid. In test of sulfate, by passing through barium chloride, white precipitate is formed from barium sulfates. In case of halogens, chloride, bromide, iodide, adding aqueous silver nitrate, they will form white precipitate. In case of chloride, white, yellow, or creamy precipitate. In case of bromide, yellow precipitate. In case of iodide. So in chemical tests for carbon dioxide passing through lime water, it would be turbid or murky or cloudy due to the formation of calcium carbonate. Test of sulfate by adding aqueous barium chloride, white precipitate is formed due to the formation of barium sulfate. Chloride, bromide, iodide, halides by passing through aqueous silver nitrate, white precipitate is formed. This is chloride. White, yellow, or creamy precipitate, this is bromide. Yellow precipitate, this is iodide.